This presentation is on winter desiccation, one of the three components associated with winter injury, the other two being freeze injury and winter or low temperature diseases. Winter desiccation is the death of turf grass leaves or plants from winter drying. Winter desiccation occurs most often on open, semi-dormant turf exposed to windy, low atmospheric humidity conditions. These conditions produce a situation where the evapotranspiration rate is greater than the water absorption rate of the plant. The lack of adequate water being supplied to the turf during desiccation are tied to temperature. Cold soil temperatures impact the viscosity of the water, making it more difficult for roots to absorb, which can be impacted by the root depth and loss in root membrane flexibility. And in some cases, the soil water is frozen, unavailable for uptake. The two major types of winter desiccation are termed atmospheric and soil drought. Atmospheric drought is normally associated with leaf tissue death. Favorable conditions for this type of desiccation are periods of sunny, windy conditions combined with low atmospheric humidity. The soil may have adequate soil moisture but is frozen or cold enough to increase the viscosity of the soil water to the point where uptake is severely restricted. Plants with restricted or shallow root systems like Poa annua are sensitive to atmospheric drought. Desiccation symptoms appear similar to drought in that the leaves are brittle, dry, and have a burned look. This photograph was taken toward the end of winter here in central Ohio. The brown areas on the green are caused by atmospheric desiccation. The brown areas were exposed to sunny, windy conditions that enhanced the evapotranspiration rates greater than the water could be absorbed. In addition, turf grass was annual bluegrass or Poa annua. The dark green areas of the putting green were covered with snow that protected the turf from the atmospheric drying effects. Atmospheric desiccation can cause leaf death. It is not normally associated with crown or plant death. However, juvenile or succulent growing turf is especially susceptible to desiccation and death may occur. In this case, a newly seeded green was covered going into winter in the higher elevations of Colorado. The covers were removed and the young plants were exposed to desiccating conditions and the plants were rapidly killed. Given an open turf, low humidity, and breezy or windy conditions, a good predictor for desiccation is temperature. When air temperatures exceed average soil temperatures by more than 20 degrees, conditions are favorable for desiccation. In this hypothetical example, the risk of desiccation is greatest during the period highlighted, where the temperature difference is greater than 20 degrees Fahrenheit. The second type of desiccation occurs under low atmospheric humidity conditions and progressively more droughty soil conditions due to a lack of rain or snow. This is soil drought. Desiccation resulting from soil drought conditions can cause plant death. In cool arid regions of the world, like the western arid regions of the United States, this type of desiccation is common. In this photograph, the high exposed areas of this green have suffered the severest desiccation. Management practices that help minimize desiccation include installing windbreaks or snow fences that can reduce wind and increase the likelihood of snow accumulating on the turf, applying a top dressing in the late fall to provide some protection to the plant's crown or growing points, or covering turf with permeable covers, and in an extreme situation, winter irrigation. Permeable covers are effective in reducing the potential for desiccation by protecting the turf from desiccating conditions. This photograph shows a green in early spring uncovered compared to a putting green on that same course that was covered. Cover removal in late winter or early spring needs to be closely monitored so not to remove during periods where drying or desiccating conditions could be present. If needed, water can be added through the permeable cover to increase soil moisture levels. Adding water during the winter to prevent desiccation is an extreme practice that I have only seen done in the western United States, in states like Wyoming and South Dakota. Where greens are covered but winter play occurs, a temporary green can be set up as shown here. You can see the flagstick with the white flag situated well in front of the green. As previously mentioned, in areas where soil desiccation is a serious potential issue, water can be applied in an attempt to relieve the soil drought condition. Applying water, however, in the winter presents some real challenges. Where soil drought desiccation occurs, most of the golf courses have their irrigation system winterized. This consists of clearing or blowing out all the water within the system prior to winter. This is done to prevent water freezing in the irrigation system, causing pipes or sprinkler heads to crack and break due to the freezing water. In areas like Wyoming and South Dakota, where a lack of snow cover exists and soil drought conditions can occur, winter watering to minimize desiccation is practiced. At many of the golf courses, a 1,000-gallon water tank or water trucks are used to transport water to tees and greens to be watered. From a practical standpoint, finding an available water source that can fill the tanks rapidly is no small concern for these golf courses. Watering is done by hand, as shown here, or using roller-based sprinklers. This picture was taken in December in South Dakota. Notice that windbreak fences have been placed near the green. Notice too the green looks a brownish gray color. The color is from a heavy sand top dressing that has been done to the green for the purpose of protecting the crowns of the plants. Some golf courses have installed frost-free water hydrants near greens to supply water during the winter. These water lines are laid well below the frost line and are installed specifically for winter watering. Water applications increase when the turf begins to break dormancy in late winter. Like freeze injury, desiccation is most likely to occur in late winter when the plant begins to break dormancy. At this time, monitoring water applications for desiccation are important. If too much water is applied, the risk of freeze injury, because of the potential to increase the intensity of the freeze-thaw cycle, turf damage could result. This concludes this presentation on winter desiccation.